topic that we're going to be looking at is the idea of the absolute value sign. So, first definition is magnitude, and the magnitude of a number says how far away is that number from zero. And this is really easy math. You're like, oh, how far is minus 3 away from 0? It's 3 away from 0. Both 2 and minus 2 are 2 units away from 0, and we use these absolute value bars. They look like ones, but they're a little bit longer. This is not 121. These are straight up and down lines. And that means how far away is 2 from 0? It's 2. How far away is minus 5 from 0? It is 5 units away. But it's very quick that students forget what the absolute value bars mean and go right away to a shortcut. And the shortcut that most teachers say and students think, like, what does the absolute value do? They just say, oh, it just makes the number positive. So if the absolute value of 2 is 2, well, 2 was positive already, and it just stays positive. But if you have the absolute value of a negative number, negative 5, it just becomes positive 5. So a lot of us get used to this idea that absolute values just make a number positive, but in reality, where does it come from? It was a distance or a magnitude function, asking you how far something is away from 0. And distances are always measured with positive numbers. So that's why the shortcut comes into place, but we just call it a distance away from 0. So that's the actual meaning of it. And here's another definition. We call this the absolute value. And do you remember this from grade 9 and from grade 10? All of our number systems, you can put a whole highlighted box around this whole thing. And the symbols are natural numbers. Those are your counting numbers. Maybe to help you remember. That's 1, 2, 3, 4. Your whole numbers, that adds in 0. Integers, positive and negative whole numbers. So now the dot, dot, dot has to go on both sides because it continues forever to positive infinity and continues forever to negative infinity. Rational numbers, in short, is any number that can be written as a fraction and this includes decimals that terminate or end. And repeating decimals. Because any decimal that ends, you can definitely write as a fraction. For example, 0.13. That ends. The first decimal place is your tenths. The second decimal place is your hundredths. So 0.13, since that ends in the hundredths, you could write it as 13 over 100. If you had something that ended in the thousands, you could write it over 1,000. You have something that ends in the 10,000s, then you could write it over 10,000. Basically, for every decimal place, you have an added 0. So if I had something like this, 0.123456, 2, 3, 4, 5, oh, there's 6 decimal places. So this will be 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6 zeros. and it's written as a fraction. If a decimal repeats, like 0.373737, it's 37/99. If there's three numbers that repeat, you'll have three nines on the bottom. One number that repeats would have one nine on the bottom. So those are your rational numbers, anything that can be written as a fraction. Your irrational numbers can't be written as a fraction. This includes special numbers like pi, but in our unit here is going to include a bunch of different square roots that don't work out nicely. Not all square roots, because you could square root of 9, well, that's just 3. So that works out to a nice thing. But if your square root, you type a square root into your calculator. So if I do the square root of 2, I look at the numbers, it's a decimal place, doesn't look like that pattern is repeating itself. And with square roots, if you do not see a pattern, most likely it won't ever have a pattern, and it will be an irrational number. Okay? We use this symbol, you used it a little bit in grade 10. This technically means element of. We sometimes, when we see that, we read it as that A belongs to the real numbers. Because it's like you're a member. You've got a membership card and everything. It's like, yes, I belong to the Real Numbers Club. And so then A is a real number, right? The number 2 has a lot of membership. It belongs to the natural numbers. It belongs to the whole numbers. It belongs to integers. It belongs to the rational numbers. It does not belong to their irrational numbers club. Wants nothing to do with it. But then it's part of all the real numbers as well. So with this, we can go to example 1. Determine each absolute value. Well, this is where the shortcut comes in really handy. I'm just going to put the answers right underneath. The absolute value of 4.2 will be 4.2. The absolute value of negative 6.1 will be positive 6.1. Because it's asking how far away is it from 0. But the shortcut just says the absolute value makes whatever's inside positive. So the absolute value of negative 3/4 will be positive 3/4. The absolute value of negative 1/2 will be positive 1/2. So if you had to put these on a number line, 0, 1, 2, 3, 4, 5, 6, 7. Does it make sense that the absolute value of 4.2 would be right there on your number line? The absolute value of negative 6.1 would be right there on your number. Yes?
I thought we were supposed to put the numbers, not the absolute.
Well, it says show the solution on order the numbers. The number could be written this way or this way. So I could, like, I'm writing them in absolute values just so you can see what they are. If you had written this as 6.1, it would be considered the same. Okay? But I just really want to point out with the absolute values that they are positive on your number line. So negative 3/4 is actually 3/4 on your number line. It would be there. And negative 1/2, which is actually half, would be there. So if we ordered these from least to greatest, you would have 1/2, then 3/4, then 4.2. than 6.1. So you can circle questions 3, 4, 7, and 9.